Okay, here's another integration by parts, 2009, question 9. So the formula again is integral uv dash equals uv minus integral vu dash. And we've got to decide which is u and which is v dash. Now there's no choice here because you only know how to differentiate inverse tan. You don't know how to integrate. So our only choice is for u to be inverse tan of x. Actually, it's x squared. And then v dash would be x. So we can then differentiate inverse tan of x squared using the chain rule, because inverse tan of x differentiates to 1 over 1 plus whatever this is all squared. So in this case x squared squared, but then we need to multiply by the differential of the brackets, which is 2x. V is the integral of x, so add on 1 to the power, divide by the new power. So this u dash is going to simplify to 2x over 1 plus x to the power of 4. So we can now put that into our formula. So uv is going to be x squared over 2 inverse tan x squared. Then we've taken away the integral of vu dash. Now when I multiply these two together, I'm going to get 2x times x squared, which would be 2x cubed on the top, and I'm going to get 2 times that on the bottom. So the 2's will cancel out, so we're going to end up with x cubed over 1 plus x to the 4 dx. And remember, it's a definite integral, but we can put the limits in later. So what we've got here still looks quite complicated, and the only way that we're going to be able to integrate something like this is if we do integration by substitution. So in this wee bit here, I'm going to do a separate little bit, and it's just the integral of that there. So integral of x cubed over 1 plus x to the 4 dx. Now the more you practice integration by substitution, the more easily you'll be able to decide what would be a good substitution. So in this one, if we make the bottom line the substitution, so let u equal 1 plus x to the 4, then du by dx equals 4x cubed, and du is 4x cubed dx. Now we want an x cubed dx. Okay, so if we do a quarter du, that's going to be x cubed dx. So when we do our substitution, the x cubed dx, this bit's going to be substituted by a quarter du. So I'll put the quarter outside, and then I'll do 1 over u, because that's what u is, du, which is going to integrate to a quarter log of u. Now we're going to substitute back in what u is. So it's a quarter log 1 plus x to the 4. Because what we want to do is now put this up here, because that's the answer to that. So we can now do our limits. So we've got x squared over 2 inverse tan of x squared minus a quarter log 1 plus x to the 4. And our limits are 0 and 1. So if we substitute in 1, we're going to get 1 squared is 1 over 2 inverse tan 1 squared is 1 minus a quarter log of 1 plus 1 to the 4 is 2. Take away, when I substitute in 0 to that, the whole thing's going to be 0 because it's multiplied by 0. And when I substitute 0 into here, I'm going to get log of 1. and log of 1 is 0. So that whole thing does end up being 0, but we really should show that we've substituted in. So it will be 0 minus a quarter log of 1, and that also equals 0. So we've ended up with a quarter inverse tan of 1. Now inverse tan of 1 is pi over 4. Okay, and because we're doing integration, we can't put 45 degrees because we have to work in radians when you're doing integration or differentiation. So that would be pi over 4 times a half is pi over 8 minus a quarter log of 2, and that is your final answer.